So this problem in your homework assignment is a little bit more lengthy. There's a lot more boxes to enter answers for. But you'll see it actually goes pretty quickly, and this video won't take too long because these first 10 boxes are just me saying, can you read a graph? Okay, can you read the x and y values and put them in these boxes? So for example, point A, we're going to put that information right here. That is located at negative 5 pi over 2. I'm sorry for the quality of this photo, it's not the best. Negative 5 pi over 2, and the y value is positive 4. Okay, so likewise, you would just fill in these boxes here. And part of the point of this is to get you in the habit of looking for these 5 key points every time you're graphing a sine or cosine function or you're interpreting a graph to make an equation. Those 5 key points are always going to be important and helpful as you go through this process. Now, down here, we have our key features, right? Amplitude, midline, period, and so on. And we can go through those for these. Remember what the midline is. That's the line that cuts through the middle of our function. And I can see that's at y equals 4. I'm sorry. This is the midline I'm talking about. Y equals 4. And the amplitude is how high up or how far down you go from the midline, which in this case is an amplitude of 3. Remember, that's always a positive number. Now the period we get by looking at this. See this dotted line that I drew around here? This is a graphing window. And it's very helpful as a concept when you think about characteristics of these sinusoidal functions, because the width of that function, the width of the graphing window tells you what the period is. This right here is the period. And I see that goes from negative 5 pi over 2 all the way until 3 pi over 2. So how many pi over 2s am I going? There's negative 5 over here, and it goes all the way up to positive 3 pi over 2s there. So I have a total of 8 pi over 2s. Okay, that'll be 8 pi over 2. Another way of thinking about this, which you may prefer, just use whatever's best for you. I take x2 minus x1, the end point minus the starting point, which in our case is 3 pi over 2 minus a negative 5 pi over 2. And if you go through, cancel out your negative signs, that's a summation that turns into 8 pi over 2. Okay, so you don't need to simplify it, but why not, right? It's not that hard. 8 pi over 2 is just 4 pi, so I would say the period of this function is 4 pi. Now the b value, we don't ever get from looking at a graph. We get from evaluating the equation for the period. And if you remember, period equals 2 pi over b. That's our equation. And we also know, we just figured out that period equals 4 pi. So we have here an equation. And I can now multiply both sides by b to get 2 pi equals 4 pi b. I'm going to cancel out a pi from both sides and divide each side by 4. Okay, basically I'm dividing each side by 4 pi. That's what I'm doing. So this is going to be equal to 1/2. b equals 1/2. Okay, there we go. And the phase shift is very easy to pick out if you know what you're looking for. Let me clear some space here. I am looking for the starting point of the parent function. So here's the left side of that graphing window, right? That's where I can think of my sine curve as beginning, even though it goes off to infinity on both sides. That's where it looks like it begins, with the point A. And that is right here at negative 5 pi over 2. Okay, so phase shift you can think of as the starting point of your graphing window. Now, how do we roll all these things together to form a sine function? Well, for this you need to know the general form equation, f of x equals a, it's a sine function, remember, so a sine b times x minus h plus k. So what do we have? This is going to be, period is 3, or the amplitude is 3, sorry. B, the b value we calculated as 1/2. I'm just looking over here to get all these things that I'm putting in the equation now. X minus, what's phase shift? Phase shift is negative 5 pi over 2. So instead of saying x minus negative 5 pi over 2, let's just call it x plus 5 pi over 2. And then it's going to be plus 4, the equation of the midline. So this is your function, and that is what goes right in here. Okay, we're not done, because if you scroll down on this problem, you're going to see this stuff. What's this? So it says, repeat the process for the exact same graph. It might not be obvious, but if you scroll from the last one to this one, it's the exact same graph. The graphing window has changed. Now, point A is up here at the top of the curve, and we are tracking this for a cosine function. Remember, the only difference between a cosine function and a sine function is the phase shift. So all of these values, look, these values are going to change, obviously, because the points have changed. But what's really important down here, these things, amplitude, midline, all those, for the most part, those do not change, because amplitude doesn't care about phase shift, midline doesn't care about phase shift. What cares about phase shift? It's not the period. Period doesn't care, so we know these things from earlier. Those don't change. B doesn't change. The only thing that changes is phase shift. And if you look at the start of the graph, right down here, the cosine function starts at negative 3 pi over 2. So we have a different phase shift from before, and that is going to play into your cosine function that you're drawing here. This thing is going to be 3 cosine, blah, 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 blah stuff, just like we did before.